Okay, welcome once again to my channel. It is again another problem here for us in integration, particularly requiring us to use the idea of the t formula or the substitution t equals to tan x out of 2. This is our simple problem here. And again, I want to remind you that before you start watching this video, because you can forget, subscribe and turn on the notification button so that you don't miss the next uploads I make. You will always be notified when I drop up something there. Let's get back to business. When you look at this integral, it is a simple one that needs us to really take a very short time. It tells us to find the integral of 1 out of 4 plus 5 cos x dx. Now what we need to do here is simple. We just need to, again, look at two ways of doing it. Either we are going to first express cos x in terms of half angles, and then from there, after expressing it in terms of half angles, we divide through by cos squared x out of 2. Or we can just bring the formula of cos x in terms of the t formula. So you can take up any of the two options, but I would like to use this option now that I've used the other ones in the previous questions. I will simply say the best option here is to realize that you simply have to let t to be equals to tan x out of 2. When you let t to be tan x out of 2, it gives an implication clearly that the cos x that we have in our question, cos of x now becomes 1 minus t squared divided by 1 plus t squared. This originates from trigonometry. Then from there, we come back to this very function. If t is equals to tan x out of 2, we need to differentiate, get the t dx. The t dx definitely becomes a half sec squared x out of 2. And then from there, the x, if you make it the subject, it becomes 2 dt divided by 1 plus t squared. What has happened here is it would be dx being 2 dt out of sec squared x out of 2. But sec squared is the same as 1 plus tan squared. But then tan squared x out of 2. I mean, tan x out of 2 is t. That's why you now see t coming in. Then from here, now I can completely say that if I can now redefine my integral by saying integral of 1 out of 4 plus 5 cos of x dx can now become as simple as integral of 1 divided by 4 plus 5, but into brackets 1 minus t squared divided by 1 plus t squared. All this, we are having dx, remember, but dx is now 2 dt divided by 1 plus t squared. Divided by 1 plus t squared. Now from this level, we can now proceed and simplify this expression first. So I'm going to simplify this expression with you. And if we do so, we shall now come up with integral of 1 divided by, first of all, here down, the LCM is clearly 1 plus t squared. If that is the case, here we shall have 4 plus 4t squared. I'm applying the LCM here carefully. And then we shall have plus 5 minus 5t squared. But we're multiplying the whole of this still by 2 dt divided by 1 plus t squared. From that point, we can now say, taking the reciprocal, of course, because you're getting 1 divided by this fraction here, so it's as good as multiplying by the reciprocal, and therefore I can say that this is integral of actually 1 plus t squared divided by, when you get 4 and 5, that gives you a 9 when you add them together. 4t squared minus 5t squared, that clearly gives us a minus t squared. Then multiply by 2 dt out of 1 plus t squared. Clearly, we can see that 1 plus t squared can cancel out. And if it cancels out, what do we expect now? We expect that now we get, integral of 2 divided by 9 minus t squared dt. And remember, this is as good as integral of 2 divided by, this is the difference of squares down, so we shall have a 3 plus t into brackets 3 minus t with respect to t. And when you look at 2 out of 3 plus t, 3 minus t, this is clearly under partial fractions, and therefore we're going to do partial fraction decomposition. So I will let 2 divided by 3 plus t into brackets 3 minus t to be equal to a divided by 3 plus t. Then plus another constant b divided by 3 minus t. And then there clearly we can see that 2 is actually equal to a into brackets 3 minus t. And then b into brackets 3 plus t. Now, from here, we can now say, we can substitute for t as 3 because of the first factor here, so that we have 2 is equals to 6b. Definitely the value of b becomes 1 over 3. We can also do the same, substitute now another value, which is particularly t equals to negative 3. And if you do so, we shall have 2 is equals to 6a. And that means the value of a now also becomes a third. Then from here, we quickly move on. And we can now say that therefore integral of, 2, not integral, but 2 out of 3 plus t into brackets 3 minus t is just as good as 1 out of 3, but we shall multiply the 3 by 3 plus t. I'm just substituting in this expression. And then plus b, which is also a third, so we shall have 1 over 3, then the 3 will be multiplied by 3 minus t. As simple as that. Then now the integral itself, the integral of 2 divided by 3 plus t into brackets 3 minus t with respect to t becomes the integral of each of these. That will be 1 over 3, but the 3 is multiplied by 3 plus t with respect to t plus another integral of 1 out of 3 into brackets 3 minus t with respect to t. When you look at this carefully, now the final answers can easily be seen. The first one gives us a third natural log of 3 plus t. The next one gives us negative a third natural log of 3 minus t plus our constant of integration. But then we need to remember that t is tan x out of 2. So I can substitute that, but then I can just use that opportunity to conclude and say integral of 1 out of 4 plus 5 cos of x with respect to x is actually equals to a third natural log of 3 plus t is tan x out of 2. I can now say divided by, because I had, a third was a common factor here. A natural logarithm minus a natural logarithm, if the bases are the same, I can be free to divide. So this is 3 minus tan x out of 2. So this becomes my answer for this particular integral. As simple as this. I want to wish you the best as you look out for more, but I can also give you a few that you can try out here and then make yourself better. So this is a very simple exercise for you or try your questions. Please try them out, and in case you get any issues, you can give me feedback on the contacts you saw on the very first screen as you're starting this video. See you in the next video.